Some comets tumble, some flare. But one object, one visitor from beyond, did something no comet should ever do. It hit the brakes on its way to the sun, and then changed its mind. Captured by the Hubble Space Telescope, this interstellar traveler called 3I Atlas appeared to reverse the direction of its own jet, venting gas first toward the sun, then away from it, like a machine performing a controlled maneuver. If this was a natural process, it would already be unprecedented. But if it wasn't, then we may be witnessing the first intentional movement of an object not made on Earth. Before you scroll away and think, that's impossible, hold on. New images confirm this phenomenon. This isn't rumor. It's not clickbait. It's in the data. In July 2025, astronomers noticed something strange. 3I Atlas was glowing more brightly than expected, and its tail wasn't behaving. Normally, comets form tails that stream away from the sun, pushed by radiation pressure. But this one's tail was pointing toward it, as if fighting gravity itself. Scientists call this a sunward jet, or more dramatically, an anti-tail. Weeks later, the object flipped, the jet vanished, and the tail began pointing the other way. Something had changed deep within its structure. It wasn't a sudden flip, like a light switch. It was gradual, a slow, deliberate transition over several weeks, tracked frame by the Nordic Optical Telescope. If 3I Atlas was venting material toward the sun, it should have slowed down. When it reversed, it should have sped up. But here's the kicker, it didn't. Its orbit stayed exactly where gravity predicted. No measurable acceleration, no deviation. So either the object's jets were perfectly balanced, or it's so massive that the thrust barely moved it. Or maybe, just maybe, it's something else entirely. Scientists tried to explain it away. Maybe we were looking at it from the wrong angle. Maybe it was just geometry, an optical illusion as Earth moved around the sun. But no, when astronomers corrected for perspective, the reversal remained. The tail didn't just look different, it was physically different. So what could cause it? The safe explanation says chemistry. As the object heated up, carbon dioxide ice on its surface may have sublimated first, creating the sun-facing jet. Then, when the outer CO2 layer burned off, water ice took over, blasting gas the other way. That's normal comet behavior, right? Except it almost never happens this quickly or this cleanly. The shift took just a few weeks. Even stranger, 3I Atlas shed an estimated 2 million tons of material. It showed almost zero change in motion. To make that possible, its mass would need to be at least 30 billion tons, far larger than most comets of its type, or was pushing evenly on all sides, like a vehicle using thrust correction to stabilize itself. If the object truly reversed its jets, we should have seen it wobble in space, small but measurable shifts in trajectory. We didn't. That means one of two things. The jets were symmetrical, canceling each other perfectly, or it wasn't using outgassing for thrust at all. For some, that's where the conversation ends. For others, it's where it begins. Physicists like Avi Loeb have raised a daring possibility. What if 3I Atlas wasn't a comet, but a probe, a deliberately engineered object performing a gravity assist around our sun? If that's true, then for the second time in less than a decade, after Oumuamua, we've caught something in the act of maneuvering. And this time, we might have the instruments to prove it. Back in 2017, when Oumuamua first zipped past, we were caught off guard. By the time scientists realized it was interstellar, it was already gone. No good spectra, no detailed data, just questions. But now, in 2025, things are different. The Vera Rubin Observatory, coming online soon, can detect tens of thousands of new objects every single night. And the new for most spectroscopic survey can record thousands of spectra at once, capturing what those objects are made of, not just where they are. It's not just discovery anymore. It's understanding. Rubin will spot them early. JWST can scan them in infrared. And Formos can take continuous spectra without shutting down other programs. If another 3I Atlas appears, we'll be ready. If it's metal, we'll see the absorption lines. If it's chemical, we'll measure the molecules. And if it changes course again, this time we won't miss it. But that leads to one haunting thought. Was the timing intentional? 3 interstellar objects in 6 years. And just as the next generation telescopes come online, another anomaly appears. Coincidence or pattern? Maybe we're being given a test. Maybe the universe is saying, now that you can watch, what will you see? Scientists across the world began to argue. Was this comet alive, or was it just pretending to be? The conservative view said 3I Atlas was simply a natural object behaving in unexpected ways. Different layers of ice, different temperatures. As it heated up, one kind of gas stopped venting, another began. Simple physics. No mysteries. But even that simple answer has cracks. For the reversal we saw to happen in just a few weeks, the internal structure of this object would need to be far more complex than any comet we've studied. The layers would have to change sharply, carbon dioxide outside, water ice deep within, like an engineered shell. And there's another problem. The direction of its jets didn't match the places sunlight was actually hitting the surface. Normally, outgassing follows heat. But 3I Atlas vented material from regions that shouldn't have been illuminated at all. That's not normal. That's deliberate. A small group of astronomers began whispering what most fear to say aloud. What if this object isn't natural? In interviews and research notes, names like Avi Loeb and Adam Hibbard raised the possibility that this could be a controlled maneuver. The first sun-facing jet acted as a brake, slowing its descent toward the sun. Then, near perihelion, the tail flipped, propulsion reversed, accelerating it back outward, just like a spacecraft performing a slingshot. The resemblance was unsettling. Imagine a probe entering our solar system, using the sun's gravity for speed, then firing jets to steer itself away. No messages, no signals, just motion, mathematically perfect. Skeptics were quick to respond. No, they said, comets are unpredictable. Outgassing can appear chaotic. There's no proof of deliberate control. And yet the data didn't fully agree with them either. Every theory that explained one behavior contradicted another. If it's carbon dioxide and water, why the perfect timing? If it's random jets, why no orbital change? If it's geometry, why the compositional shift in the gases? Piece by piece, the natural explanations began to sound as extraordinary as the artificial ones. The truth was hiding somewhere between numbers and imagination. For those who believe in extraterrestrial technology, this wasn't the first time the universe had dropped hints. Back in 2017, Oumuamua had shown similar mysteries. An object with no visible tail, no detectable outgassing, yet it accelerated as if something was pushing it. It looked like a shard, a reflective sliver, tumbling in a way that didn't match any rock or comet we knew. Loeb called a light sail, possibly a fragment of alien technology. Most scientists laughed it off. But now, with 3I Atlas showing behavior that looked controlled, laughter was replaced by silence. No one wanted to be the first to say it, but everyone was thinking it. What if the galaxy is sending us visitors, and we just started noticing? If that's true, then 3I Atlas isn't an accident. It's part of something larger. And maybe, just maybe, the timing of its arrival was intentional. The Rubin Observatory is finally ready. The Fromos spectroscopic array can see thousands of objects in a single sweep. JWST is watching from space. We're building the eyes to see beyond our solar system. And suddenly, the sky sends us a test. Was that luck or design? But even if it is artificial, there's another question no one wants to ask. Why come here? Not to visit, not to orbit, not to land, just to pass through, almost teasingly close. Some think these objects might be probes, small autonomous scouts that map the stars without ever stopping. Others imagine them as ancient remnants, machines left adrift by civilizations long dead, still following programmed paths across light years. And maybe that's why they stay silent. They don't need to speak. Their mission ended before we were born. It's a haunting thought that the first evidence of other minds might not be alive at all, but fossilized technology still doing its job after a billion years. No blinking lights, no messages, just motion. But for now, no one knows. All we can do is watch, because 3I Atlas is still out there, falling toward its moment of truth. Perihelion, October 29th, 2025. The day it swings closest to the sun. What happens in those hours could change everything. If it behaves like a comet, the mystery fades. But if it does anything else, if it brightens suddenly, changes course, or fractures in ways no comet can, then the question becomes unavoidable. Who or what is steering it? If someone or something is steering it, then time is running out to find out who. 3I Atlas is moving fast. Once it slings past the sun, it will race back toward the outer solar system and vanish into interstellar space, just as quickly as it came. Every hour counts, and this time, humanity isn't caught unprepared. The astronomical community has evolved since the days of Oumuamua and Borisov. Back then, observation time was limited and expensive. Every hour on a major telescope was a competition. Studying one strange object meant abandoning dozens of others. But the new generation of instruments has changed that. The Vera Rubin Observatory, high in Chile, will soon scan the entire visible sky every few nights, spotting tens of thousands of moving objects each evening. And when it does, every detection becomes part of a global web of data. The system flags anything unusual, unexpected speeds, odd brightness curves, strange orbital shapes. Then there's for most, the massive spectroscopic survey that can take thousands of spectra in one sweep. Where older telescopes had to choose a single target, for most can observe everything. Asteroids, comets, faint bodies all at once. Together, they form the backbone of a new kind of astronomy. One driven by automation, pattern recognition, and sheer data volume. Every night, machine learning algorithms will process terabytes of images, separating comets from asteroids, asteroids from supernovae, and supernovae from noise. The flow of alerts, millions per night, feeds into a vast network of observers, amateurs and professionals alike, who decide what deserves deeper study. The system acts like a nervous system for the planet, detecting and reacting to cosmic events in real time. For interstellar objects like 3I Atlas, this matters. They don't wait for us. They move too fast, vanish too quickly. By the time Oumuamua was noticed, it was already leaving. But Atlas will be different. The network is ready, the instruments are aligned, and the algorithms are tuned. When the data starts streaming in, we'll know instantly if it behaves like anything we've seen before, or not at all. But even with this global machinery in place, decisions still come down to people. Algorithms can flag anomalies, but only human judgment decides what's truly worth chasing. Spectroscopy, high-resolution imaging, multi-night monitoring. All these resources are limited. Every scientist must choose where to point their telescope. That choice defines what we learn and what we miss. And that raises a deeper question. In this new age of automated discovery, who decides what's important? What if a single misclassified data point causes us to overlook the most extraordinary discovery in human history? Astronomy is becoming industrial. Instead of a handful of researchers studying one object at a time, the field now relies on global collaboration and massive databases. The pace is faster, the stakes are higher, and mistakes are easier to make. But so are miracles. In the next decade, discoveries like 3I Atlas may become common. What was once a cosmic rarity could soon be a nightly headline. Some of these interstellar visitors will be ordinary, dusty, frozen, forgettable. But a few will defy every model we have. Those will demand attention. Those will force scientists to reconsider everything they know about planetary formation and cosmic travel. The revolution happening in astronomy isn't just technical. It's cultural. It's about how we think, how we share information, how we react when the unknown appears at our doorstep. For centuries, discovery meant a single person at a telescope staring through glass. Now it means algorithms scanning the heavens while teams around the world debate what the results even mean. And somewhere out there, beyond the glow of our sun, another object might already be on its way. We'll see it sooner next time. We'll track it better. But will we understand it any more than we do now? The truth is, our technology might be advancing faster than our imagination. As we perfect the systems to spot the extraordinary, we must also learn to recognize it when it stares back. As 3I Atlas races toward the sun, astronomers prepare for what could be the most important few hours in modern history. Every telescope on Earth and in orbit is aimed at the same point in the sky. The data streams are synchronized, the algorithms ready, and yet, no one truly knows what they are about to witness. The object's closest approach, its perihelion, is predicted for October 29, 2025. In that moment, the heat of the sun will push its composition to the limit. If it is ice and dust, it will erupt with light. If it is metal, it will stay cold and silent. Either way, the universe is about to answer a question that has haunted us since the first telescope was lifted toward the heavens. Are we alone in the dark, or are we being watched? Some expect a routine show, a flare, a tail, maybe fragmentation as pressure tears apart. But others fear something stranger. If the object suddenly brightens or changes trajectory, if it emits radiation that doesn't match any known element, if it remains intact against heat that should destroy it, then the old explanations will collapse. What happens after that is anyone's guess. If artificiality is even suspected, the first debate will not be scientific but political. Who gets to study it? Who owns the discovery? Will governments classify the data to prevent panic or rush to claim it as a national achievement? For decades, the world has talked about how it might respond to contact, but no plan has ever been tested. The United Nations does have an Office for Outer Space Affairs, a quiet department that theoretically coordinates international policy in the event of extraterrestrial discovery. In practice, its role is symbolic. No one has rehearsed what to do if a probe, or what looks like one, enters the solar system. There is no emergency protocol for a message that doesn't speak. If confirmation ever came, the implications would unfold faster than any government could contain. Religions would interpret, markets would react. Every human being would look up differently at the night sky, because artificiality would mean one simple truth. Interstellar travel is possible. Someone has already done it. That realization would change everything. It would mean that intelligence can outlast its home world, that technology can survive extinction, that the universe is not silent but patient. It would force us to confront what we are doing with our own civilization. How fragile it is, how brief our time might be if we do not learn to endure like the travelers who left this artifact drifting between the stars. But even if 3I Atlas proves natural, even if it turns out to be nothing more than a bizarre comet behaving badly, the lesson remains the same. The universe still has surprises. Our instruments may grow sharper, but our understanding is still young. Every object like this reminds us that discovery is not about certainty. It's about curiosity, the willingness to follow the impossible until it becomes real. In the end, 3I Atlas might leave as quietly as it arrived, a fading point of light sliding back into the interstellar dark. Years from now, students will scroll through its data, its spectrum, its orbit, its strange reversal, and wonder why it came. Maybe it was a message, maybe just a stone, maybe both. What matters is that we noticed, because noticing is the first step toward answering the oldest question in human history. Are we truly alone, or are we part of something larger, watching and being watched across the void? 3I Atlas is already on its way out, heading back into the dark between the stars. But the silence it leaves behind is louder than ever. It is the sound of a species beginning to listen.